Welcome to This Explainer. Today, we're diving straight into what is, hands down, the most deceiving illusion in all of machine learning.
Picture this. Your brand new model hits an astonishing 99% accuracy. The whole team is hyped, you pop the champagne, you ship it out into production, and then
reality hits. Out in the real world, it just completely falls flat on its face. So what on earth went wrong?
Well, the culprit is without a doubt the sneakiest bug in our field. It's called data leakage. This happens when information somehow sneaks into your training data, information that the model would literally never have access to at prediction time in the real world. Think of it exactly like a student somehow getting a copy of the answer key right before a massive final exam. Of course they're going to score perfectly, but, they're hitting that 99% because they cheated, not because they actually understand the material. And just like that cheating student, the exact moment your model faces a real, unscripted problem out in the wild, without that hidden answer key, it's completely lost. Your model simply found a mathematical shortcut that worked beautifully in your dataset, but that shortcut just doesn't exist in reality. Now here's the truly tricky part about all this. Leakage is almost always subtle, and it's totally accidental. Nobody is intentionally handing the model the answers on purpose. Instead, it just hides silently in the data. Let's look at a classic medical case to see how this plays out. Imagine you're building a model to predict which patients have a specific disease. It's scoring incredibly well. But then you dig a little deeper and find the culprit. One of the input features the model was using was actually the number of medications prescribed for this disease.
Think about that for a second. A patient only gets prescribed those medications after they've already been diagnosed by a doctor. So that specific feature is essentially a leaked copy of the answer. It's literally information from the future. It's data you would never, ever have when you're actually trying to predict the disease in a brand new patient. The model didn't learn to detect the disease, it just learned to read a clue that completely gives the answer away.
So this timing issue, future clues hiding in present data, is one of the two main ways leakage happens. But the second culprit is arguably even sneakier, and that's your own data preparation. Say you clean or scale your entire dataset before you actually split off your test set. When you do that, the mathematical averages of the test data quietly bleed right into the training data. You've accidentally given your model a sneak peek at the final exam, and without even realizing it, the test is no longer fair. And here's what makes all of this so incredibly dangerous. Leakage doesn't announce itself. You aren't going to get a system crash. There's no flashing red error warning in your console. Instead, it disguises itself as a suspiciously good result. And honestly, usually, everyone is just too thrilled with its success to even question it. This invisible danger is exactly why experienced practitioners have developed what I like to call a healthy paranoia about results that look just a little too good to be true. A 99% score shouldn't just make you celebrate, it should absolutely make you deeply suspicious.
Which brings us to our final point here. Next time you see those near-perfect scores, I want you to stop and ask yourself one hard question. Is this real, or is my model just cheating? Keep that in the back of your mind, and you'll save yourself from the most deceiving trap in machine learning.